All right, everybody ready? 162, sir. That's where the practice problem is. And the other thing. But the first thing I want to do is we're going to talk about this first. So, when we're talking about circular motion, what has happened is you're spinning something. As you spin it, it depends on where you let go of it, on where the velocity is going to go. Y'all understand that, right? Y'all play softball, baseball, play maybe football, things like that. You know that. You know, depending on how you throw it, where it's going to go. Okay? So here we have our R, which is our radius, and our V is our velocity. So when we're looking at this, we're using the R as a change in position. Okay? Also represents V for velocity. So we're doing average velocity is displacement. When you see something that has a line across of it, that's displacement. Change in position. Remember what position was? That's usually X, isn't it? Okay? So XV is what we're going to be talking about here over change in time. So if it gives you an equation and tells you position, it starts with 1, position final is 2, how are you going to find change in position? You're going to take 2 from 1, right?
Yeah, position 2 from position.
Yeah. Final position minus the initial position. Same thing with the time. If it said it started at 1 minute, 1 second, and it ended at 2 seconds, what is my change in time? 1 second, because I'm taking 2 from 1. Okay? This math is easy. Thank God. We're ready for some easy math, right? Also, so this is for average velocity. If we're talking about average acceleration, we've seen that A before, haven't we? And we've seen the line. So every time you see a line now, you'll know that means average. So if we're looking over for average acceleration, that's going to be my change in velocity over my change in time. The other equation that you need to know is this one right here, and that's acceleration centripetal equals speed squared divided by radius, okay? Those are the only ones you're going to need to know. So let's look at the sample problem that we have on there. And JP, do you mind explaining that one to me, please, sir?
What page is it again?
Page 162. So I'll read it if you'll just tell me what the variables are. You got it? You getting there?
Yeah, I'm on it now.
Okay, cool. So it says here, it says a 13-gallon rubber stopper is attached to a 0.93 meter string. The stopper is swung in a horizontal circle, making one revolution of 1.18 seconds. Find the magnitude. So we have the mass, which is 13 grams, right?
Mm-hmm.
R stands for what, JP?
R is your position.
Your radius, correct. That's the position. That's a good one. 0.93 meters. What's my T stand for? Time. 1.18.
Yeah.
And we are looking for the tension force. Remember, FT stands for tension force. So the only thing they did here is they used AC equals 4 pi square R divided by T. So get your calculator. Let's see if we can try this in our calculator. So the 4 pi, we're just going to basically do that, aren't we? So if you have your calculator, first thing we're going to do is do our alpha y equal, right? To get it. After we get our alpha y equal, then what we're going to do is we're going to do our 4. Then we're going to use our pi. Our pi button, where's that at?
You gotta press second.
Second power, okay. And then what are we doing after that?
Doing it every radius.
Well, it says squared, right? So we're going to use our little caret key without the blue button, right? And we're gonna put the number 2. We're gonna open our bracket. We're gonna do 0.93, close our bracket, go over so we can go down. We're gonna do a parentheses again, aren't we? Parentheses 1.18, close parentheses, and now we're gonna square that. So can we use the x plus the x squared key instead? Sure, why not? Over and enter.
What goes on the bottom?
1.18 squared. Now, what did you get?
26.36.
You got 26.3, okay. What did everybody else get? I didn't get that answer. You know why I didn't get that answer?
Because it's set in the wrong mode.
My setting was in the wrong mode. My setting was in degree. I'm going to clear it. And I'm going to do second answer again.
$24.1.
That's what I got, 24.1.
That's what you see.
You got 26. So let me ask you a question. Did you do the square or did you do the caret square?
The carrots, but you know,
Yes.
That's where I messed up at.
So it does make a difference, doesn't it? So using this button here, I think you got it right. So using this button, use the square caret key. That's more important, isn't it?
Yeah.
Don't use an x squared button.
Yeah, that's what I used the first time.
Don't use an x squared button. Write your little note on there because you'll need to know that. So that when you have the test that I'm going to be giving you a little bit, you'll know, right? Everybody good so far? Okay, so let's see what else we got. Then it says use Newton's second law to find the magnitude. So what are we going to do, JP?
You're gonna subtract it?
What does it say? What is it doing there?
It says find the magnitude. It says find the magnitude of the tension and force exerted by the string on a stopper.
So it says use Newton's laws where I'm at. So it says force tension equals mass times the centrifugal acceleration, right, sir? So how are we going to do that?
Force tension.
Substitute. Well, we're trying to find the F1.
Yeah, we're looking for the force of the tension is what we're looking for.
You're gonna
plug in 13 with number just now, which is 26.
Yep. So we're looking at the mass. On here, this is grams. Why they change it to kilograms?
be 1,000 pounds bigger.
Because we're trying to find newtons. And to be able to find newtons, you'll need to use kilograms instead of grams. So write your little note beside yours that says you have to make sure your units are in kilograms. Remember how to do kilograms? You do your grams, right? Grams on the bottom, kilograms on top to do your math, or move your decimal to the left or the right. So let's see. Open bracket, 0.013, close bracket, 26. I got 0.338, and they moved it to 0.34. Everybody good so far? Fantastic. All right, Freddie, you ready? What I want you to do is I want you to look at the problem, number 1, and think about what formulas we're going to use for that, please, sir.
Talking about the first practice problem.
Mm-hmm. So, Freddie, we're looking for acceleration centrifugal, aren't we, baby? Okay? We're going to take our velocity squared and divide it by our radius. But before we do that, we need to know what our velocity is and what our radius is. Okay? So let's look at the problem. A runner is moving at a speed of 8.8 meters per second. 8.8 meters per second is which one?
Velocity.
Velocity.
Okay, Freddie. So that is 8.8 meters per second, right? That's my first one. So let's see what else we got. It says round the bend with a radius of 25 meters. All right, what's my radius? 25 meters, right? Okay, so my equation is 8.8 meters per second, and I got to square that, don't I?
Mm-hmm.
And I'm going to divide that by 25 meters. All right? So, Freddie, if you'll put that in your calculator. I don't need to change my mode or anything, do I? Nope.
No.
Okay, alpha y enter. I got 8.8. I need to put a bracket around that. And I'm going to do my caret square. And then I'm going to divide that by 25. What'd you get, sir? Yep. So I'm going to say it's 3.1 meters per second squared. Perfect. All right. If y'all will please write that down in your book for number 12. And I'm going to give you a few minutes to see if you can work on question number 13. And then we're going to do it in class together. And Jared, I think you're going to do that one.
13.
Mm-hmm. Number 13 says an airplane traveling at 201 meters per second make a turn. What is the smallest radius of the circular path in kilometers the pilot can make to keep the centrifugal acceleration under 5.0 meters per second squared? So I'm going to give you the formula. Okay? We're looking for AC equals V2 over radius. But we're looking for radius, aren't we, sir? So radius will equal velocity 2 over AC. So I'm changing that formula to get what I know. I need to know what velocity 2 is, and I need to know what radius is.
You need to know what AC is?
Nope, we will know centrifugal force because it tells. Oh, you're right.
Yeah, I was about to say because
Oh,
it's
I
velocity.
need AC. Woo! Thank you, sir. All right. So it says an airplane travel at 201 meters per second.
That's your velocity.
Which one is that one, sir?
V2.
Huh?
V2.
V2? Okay. What number is that?
201 meters.
201 meters per second. Okay. And then what's my centrifugal acceleration?
5.
5. Yep.
Squared.
5 meters per second. Very good.
So you don't have to square your volume.
Well, we're getting ready to. What I just did here is I just did my volume by itself. I didn't square it yet. So let's go ahead and put it in our equation. So go ahead, sir. If I'm taking this and I have this, now what I'm looking for is the radius. I'm going to take my 201 meters per second and I'm going to square it, right? I'm going to divide it by my AC, which is 5.00 meters per second. So let's put it in our calculator.
8,080.2.
Okay.
Yeah, I got the same thing.
Very good. Now, what is this in?
Meters.
What do we need to have it in?
Kilograms.
It says here in kilometers. So,
Yeah, kilograms.
how do I change that to kilometers, sir? This is in meters.
Times that by 1,000.
Meters,
Divide.
kilometers. So let's think here. We got meters, we're gonna get kilometers. Where does the 1,000 go? On the top or the bottom? 1,000
Like the
kilometers in a meter?
The bottom.
1,000 meters in a kilometer?
Yes, ma'am.
Okay, let's put that in our calculator and see what we get. So we're gonna do our second answer. And we're gonna times that by alpha y inner 1/1000. Close my bracket and I get 8.08. Is that what you get? 8.08 kilometers. And that's my answer. Are you good, sir? All right, copy that down. Can I erase number 13?
Yes, ma'am.
I mean, number 12. All right, let's look at number 14. Says a 45-kilometer merry-go-round worker stands on a ride platform 6.3 meters from the center, shown in figure 11. If her speed as she goes around in a circle is 4.1 meters per second, what is the force of friction necessary to keep her from falling off the platform? So, force friction equals force centrifugal, which will equal mass times velocity squared over radius. We are using the mass times velocity squared over radius.
Your mass is gonna be 6.1.
Okay, go ahead, sir. Our mass is what?
Your mass is gonna be 45.
45 kilograms, okay?
Yes, ma'am.
All right, what's our velocity?
6.3 meters, isn't it?
That's our radius. The radius, because it's meters, right? So you know that's radius.
5
Okay.
meters a second.
So 6.3 meters, and my velocity is 4.1 meters per second squared.
Mhm.
Okay, ready? You ready? Or JP can do it. JP, you ready?
Yes, ma'am.
Because I'm going to give him the last one. All right, sir. So we're going to plug and chug, right?
Yes, ma'am.
So we got 45 kilograms, right? We're going to times that by 4.1 meters per second. Well, we got to square that, don't we? And we're going to divide that by our radius, which is 6.3 meters. All right, sir, plug it in your calculator and tell me what you got. Alpha y equal 45 open bracket 4.1 close bracket, and I'm going to do my caret 2 down 6.3. What'd you get, JP?
Still plugging in there.
Okay.
$120.
Yep.
21.
Okay. So you got 120.0714286. Is that what you got?
Yes, ma'am.
Tell me what it is in scientific notation. Go ahead and change yours to scientific notation. Remember, go to mode, hit over to scientific, and then do second, answer, enter. What do you get, sir?
1.200714286 E2.
Okay, so that's 1.2 times 10 to the second power. Perfect. Am I going too fast? I'll slow down.
I got it.
Good. Freddie, you good? You good? Are you ready for the last one?
This one. Number 15.
Mm-hmm. There's your formula, sir. We're going to find centrifugal acceleration first, and then we're going to find force tension second. Should make it look like a map. A 16-gram ball at the end of a 1.4 meter string is swung in a horizontal circle. It revolves once every 1.09 seconds. What is the magnitude of the string tension? All right. So what is our radius? So here, this question, sir.
0.8.
Okay. What is our time?
The time is 0.09.
Okay. Should be able to do this, right, guys? So this is 4 pi, and our radius, you said, was 1.4 meters, divided by our time, 1.09 seconds, and we will need to square it. So if y'all will plug that into your calculator.
You don't need to square it on the top there?
No. Because this says 4 pi r, right? Over t squared. I didn't square it.
I need to take it out of scientific mode.
I would. Okay. Alpha y, enter. 4, and I'm going to do the pi, which is above the caret key, right? Open bracket, 1.4, close bracket. Go down, which is over. Open bracket, 1.09, close bracket, caret, and 2. What did you get, sir? Okay. 14.807,607.83. Can we round it up to 15? Make it easy. So now what we're going to do is we're going to take our mass. What is our mass?
16.
16. And we're going to multiply that by what? 15. And what do you get?
240.
Now, why did I change that to kilograms, right?
Yeah, so,
No, it's okay. Let's not change the kilograms. Let's do grams real quick. What do you get?
I got 240, it's probably 2.4.
240?
But I
And-
did, 60, not 15, but if it was that, it would be 2.4 or 2.4.
Right. So if we did it this way,
Yeah.
you got 240 grams, right? If I want to change that to kilograms, how do I do that? Grams are on the bottom, kilograms are on the top. 1,000 grams in 1 kilogram. Yeah, that sounds good. So then we get what? Use your calculator.
Thank you for it.
0.24 kilograms. Simple stuff. This is a very, very simple section. You got one more section to go and then you'll be done. So this is what's going to happen. Those of you that are at home, you will take your test here in class on Thursday. Y'all will have yours to take home with you tonight. What I'm going to encourage you to do now is to go ahead and work on section 4. Okay? And then we can kind of go over section number 4 with you. So you'll have tomorrow's work done so that you can focus all your time on your test. Okay? So go ahead and do that. I'm going to stop that so I can post it.